Hi there, chemistry students. Happy first day, happy first week. This first week video is going to be both the overall video on how the class is going to work. I'm going to go through the syllabus and assignments and expectations and all that kind of stuff. So it's going to be a little longer. And then I also will do what I normally do for these videos at the beginning on the Tuesdays of the week. I will also talk about the specifics about the lab that you're doing this week. So let's start out with just kind of the class overall. And you notice that I'm here in the Google Classroom. I put here that there's a little spot here if you have any questions for each other. You can use that. You can also, if you want to reach out to each other, use the Meet link. If you click that, you just go to a electronic room that is only available for chemistry students, for these chemistry students. And if you can meet each other there if you have questions and want to talk about the lab. Okay, so maybe that's enough about that. Most of the things that you need to know are in this classwork page. I've got class info here. The big thing here is the chemistry syllabus. I have a little bit more expanded, more in detail version of the weekly plan here, but the chemistry syllabus is pretty good to give you the idea. Maybe let's just start with that. And I'm going to open that guy up. Zoom it in for you. I'd like you to think about, I changed the way I'm going to teach chemistry, actually for physics too, entirely. I just threw everything out because we have to do distance learning. Let's do it a whole different way. And I'm kind of excited about it. I think it's going to be good. What I'm doing is we're going to, I'm going to send home a giant tote. I've got that right here, this chemistry lab tote. It's going to include all the chemicals and all the equipment that you're going to need. It's a big, 40-liter Rubbermaid tote, about this big, with all the chemicals and everything you're going to need. You're going to take that home with you. I'll be available for you to pick them up Thursday, Friday, and Monday. You can see that on the classroom. I'll point it out again. Anyway, you're going to pick that tote up, and then next week's experiment, we will actually have some equipment for you to do the experiment. This week's experiment is going to be pretty much all as a simulation, a computer simulation, but just to kind of get used to the rhythm of the class and the processes and the assignments. And so I kind of gave you a softball for this first week. Okay, so I'm going to send you that chemistry tote. Let's go through like how the week will kind of, no, maybe not yet. Let's just talk about why I changed the process. So the way we're going to learn this. When you've taken all these other science classes, you've probably heard them talking about the scientific method, of course. And Mr. Scott and Mr. Hartman, I know, teach the scientific method, and they talk about how science is like you're watching a sports ball game that you've never heard of before, you've never seen before, but you're trying to by watching, you're trying to figure out the rules. And observing and watching, you're trying to figure out the rules. And that's what science is. We don't know the rules in nature, but by watching and observing and measuring and making predictions and seeing if they're true, all of that is ways that we figure out what is true and what are the rules about nature. And that is the scientific method. And you guys have practiced that in all of your other science classes. I'm going to do that with your investigations, of course, but we're going to take it just one more step further. We're going to go and do the scientific process, the process that this world does to figure out scientific truths and consensus. So the way that we do that is by peer review. And what scientists do is they investigate stuff, and then they go, hey, did you get the same answer as me? And then the other person says, well, yeah, I did. Well, let's check with that guy. Oh, they got the same answer? so-and-so did not get the same answer. I wonder what's different about that. Did we do something different or did they do something different? And then they try to find a scientific consensus by doing peer review of each other and then finding consensus. And that's the scientific process. And it takes years and it takes hundreds, thousands, millions of scientists to come up with real answers to scientific questions. So we're going to use that process in a small way in our classroom. Okay, so that's what we're doing. Let me just show you how that looks in this class. So every week, we're going to do an investigation. You're going to write a paper about it, and then we're going to start all over the next week. Do an investigation, peer review, paper, start over again. We're going to do 7 of those investigations, 7 papers, 7 peer reviews. That's how it's going to roll. But let's just look at it more specifically. The peer-reviewed Science Weekly plan is going to look like this. We start on Tuesday, like today. I introduce you to the investigation that you need to do. I tell you about the safety and make sure that you don't burn down your house or poison your siblings or any of that stuff. And I help you, kind of show you how to set up the equipment, make sure that you know what you need to do. So that's on Tuesday. I help you out, and those are live on Zoom. That's the important thing, live on Zoom. On Tuesday, you need to be here on Zoom with me, and we're all together figuring out how to do the experiment. Wednesday, I'm kind of treating it as a work day. You are going to be working on your experiment, what you learned, and you're trying stuff out, setting it up, actually making measurements. This is also the time that you should be making your initial video. That's this guy, the initial video. That's just sent to me. The initial video it's not going to anybody else, just to me, just for me to know that you know how to set up your stuff, you know how things work, you also know the safety precautions, and that everything's going to go okay, and that you understand what we're trying to figure out. It's kind of help me help you. And then also to know that you actually did it. Those are both those things. That's due on Thursday at 9. You've got 2 days. You got Wednesday all day to work on that and get that in. It's very important that that comes in on time. I need to know that you're ready to go. So Thursday, 9 a.m. If you don't turn it in on time, you lose 60%. If you turn it in on time, like seriously, if you just turn in a video of okay, not anything. It can't be actually offensive or anything. But if you turn in pretty much a blank screen video, you will get 60 points if you turned it into Google Classroom on time. And then all the rest is just cream at that point. So, turn in your initial video on time, and then do your initial trial on Wednesday. Thursday, we are going to meet live on Zoom again. That's a live on Zoom thing. We will compare your results, your initial results, and see, hey, did we get similar results? And then be like, I don't know, why did you get that? I don't know. Did you remember to tear the scale? Did you blow, and we'll actually try to figure out what went wrong, or if there was anything wrong, or if we're really doing awesome and everybody looks like they have the right answer, well, perfect. So Thursday, we're gonna meet together, talk as little lab groups, try to figure out what went right, what went wrong. And then you still have Thursday and Friday to continue your investigation and writing your draft paper. So the goal for Friday is to write your draft paper. We are not meeting on Zoom. I will be here during class time for any questions you have. I have to be here. So I'll be here and I'll answer any questions you have about the investigation or your paper or anything at all. So Friday, you're working on your investigation and your draft paper, and you have until Sunday to turn it in. I need it by Sunday at 6 because then I need to make sure they don't have any names on them and all that stuff, so I can email them out to your classmates. They'll be anonymous. Nobody will know whose paper they're looking at, or at least they shouldn't. I'll be emailing them out to other students, and then they will get those Monday morning, and and all of you will peer review a couple of papers of your classmates, of your peers. You are not grading them. Don't worry, you are not grading the papers. I'm grading them. You're just giving them feedback about, this was confusing, this made sense, nice work on this, I like this part, this was hard. You know, that's what you're doing with the peer review. Helping them out, and also saying, I got a different answer. Did you try this? That's what you're doing with peer review, kind of a further of that the lab groups collaboration. Okay, you turn in your peer review by Tuesday, 9 a.m. You have one day, you have Monday to do your peer review. I'm hoping you use your class time to do that. And then Tuesday, we'll all get together. We've all looked at a bunch of papers. We've kind of got an idea of what the class is thinking about. And hopefully we should be able to, in class, come up with a class consensus. What answers do we agree on? And then I'll introduce the new investigation for the week, and you'll get started on it. Okay, so that is the whole week, except for the one part. The final paper is still due. You haven't turned in the final paper. I'm giving you pretty much have a draft paper. You've seen other people's things. We have a consensus. You know, you've got from Tuesday until Friday to work on your final paper, not because I want you to work on it that long, but just because I want to give you a lot of flexibility. And there's no time crunch anymore to get it to your peers or anything like that. So turn in your final paper by Friday, and hopefully it'll be nice and easy because you've already written the draft and you've gotten a bunch of feedback from your peers, and you just add that into your paper and everything's great. Okay, so then grading. That's the other part. Grading, do you notice that all 7 of your initial videos are going to be 20%? All 7 of your draft papers are going to be 20% of your grade. All 7 of your peer reviews are going to be 20% of your grade. The class participation is going to be 20% of your grade. And your final papers are going to be 20% of your grade. And you probably notice that there's no tests or quizzes, because there's not. There's no tests or quizzes. It's just this: investigate, peer review, write a paper. That's it. That's what we're doing the whole rest of the quarter. Every week, a new one. And you just got to keep on the train. It's really important that you turn in these initial videos, the peer reviews, and the draft papers on time. There's kind of a big hit if those ones aren't turned in on time. You lose a lot of grade points just for not turning those in on time, because if you don't turn them in on time, then your peers aren't able to continue on with their parts of their investigations. So you're kind of holding everybody else up. I just want you to get them in, get it done, keep rolling, don't slow down. And in that same vein, none of these things are talking about grammar or punctuation. Not that they're unimportant, but you know, it's okay. We've got a lot of things to cover. I want you to just do the best you can, especially on these draft papers. I mean, you're just trying to get your information out there, and that's what all the peer review and the revisions are for, right? Don't worry about it on the draft paper. Just get your information out there, let people know, and we'll tell you if it's not clear. If you put a big word salad out there, it's not going to be clear. But if you forget a period or a comma or use the one wrong word or whatever, we can probably figure it out. If you're clear enough with us and we can get it, that's pretty good. That's what we're going for. Just understanding and clarity for other folks. And that's a good thing to work for. Okay, so if you need help, I will be around even on those Monday, Wednesday, and Friday when we don't have like live class where you have to check in. Tuesday, Thursday, you do have to check in though. That's part of that class participation, 20% of your grade. You have to be there for those. But Monday, Wednesday, and Friday, you don't have to check in, but I am there for questions during our class time, and I'm happy to help you. I'll probably be bored out of my mind. So you check in, see if you need help. I will be happy to, I'll help you set up your equipment and everything. You can also, at any other time, you can email me or call. And then I'm going to try to be available from 2 to 4 every day also for help, but you'll have to let me know how to reach you because I'll be, available for both my classes at that time. So call or email and say, hey, can we meet? And I'll be like, yep, let's go to the Google Meet link or whatever. But that's a good time to catch me too. And you know that you can meet up with your other classmates on that Google Meet link. And then these are the 7 investigations we're going to do. And that is the entire syllabus. Not too bad. Okay, so then let's look at the assignments. Scrolling down to the assignments, this is our week 1. These are all the assignments every week. It will look like this. There'll be an introduction, there'll be an initial video, draft paper, peer review, lab group and class participation, and final paper. These 5 assignments will always be there with an introduction. Same thing, if the only thing that'll be different is the introduction and the resources and the investigation that you're going to be doing. But the same assignments will always be there. Okay, so I want you to notice that I've got a rubric here so you can read through, see how I'm grading it and what you need to do. I hope that's clear. If it's not, you let me know. Look at that, somebody turned one in already. That's amazing. And then there's the draft paper. I've got some information about the sections and what I'd like in each section, what questions to answer in each section. And then there's a rubric. You can see how I'm grading it, what you need to turn in. Same thing, well, it's a little different on the peer review. Peer review, I made it a Google form, so you just fill in the questions about each of the papers that you're looking at. I want to remind you that you are not grading these papers. Any of their feedback you're giving is not going to change how I grade their papers. I'm grading the papers. You're just helping them make a good final paper. Okay, and then lab group and class participation. That's mostly me, but it's going to be a Google form. I'm going to be asking you about like, hey, who helped you out with your experiment? Who gave you an idea that helped you get a better result? All that kind of stuff. That's kind of in the Google Forms. And then the final paper, I've got the rubric there again, and everything should be clear. All of them have their due dates up. Those should go into your Google Calendar, should have all those due dates. Here's the assignment, the initial videos there. And then I also have, when can your family pick up your chemistry tote? That should be done by Thursday because I need to know when if everyone can get their chemistry tote picked up. And then I think that's all for that. Did I cover everything? Yes. Oh, this week's investigation. That's what we need to do. So here in the introduction and resources, you notice I'm going to be putting this video that I'm talking about, that I'm talking in right now. It's going to go right here into the introduction and resources as soon as I'm done. And they'll always be like kind of a document that kind of explains it, and then a video that helps you kind of walk through stuff. But here's the document that explains what to do for this investigation. Once again, it's a softball. I made it pretty easy. What are the rules of the particles of an atom? This in an atom. That is the main investigation question that we're trying to answer with these computer simulations today, or this week. So I've got a little introduction, give you like some, some definitions and resources. And then I've kind of, even though this is our main question that we're trying to answer, I also have like some questions to investigate, like kind of, if that was too overwhelming, I give you kind of some little bite-sized questions to kind of get you rolling, So while you're in the sim, try to answer these and you'll probably end up figuring it all out. Okay, so I've got this, we're going to start with the build an atom simulation. That's what you're going to do. You go here, you end up, yeah, I am still screen sharing, right? Yeah. you go here, we end up with this build an atom, we click here, you can, what I'd like you to do is click this net charge and the mass number and then this stable, unstable. Those are all important things. And then you get to put some protons in and some neutrons and some electrons and see what happens. What happens to the element, the net charge and the mass number? What matters? What, you know, and then you go, oh, it didn't want to go in there. And oh, look, it's unstable. Why is it unstable? That's weird. It's not getting any more stable. Anyway, so these are this is what's going to help you answer those questions. You'll notice that it also has 3 parts. There's this one that we just looked at. Then there's the symbol. And you notice that is how chemists describe elements, kind of tell us what an element is. I want you to know what these I want you to know what those 3 numbers really are and how they relate to what you were looking at before. And then the game is a really good, okay, I think the game is fun because I'm a nerd, but that's cool. So the game is a good way to figure out if you really know what you're talking about. If you get one wrong, you can go, I thought this was the answer, but for some reason it's not. And you can use this as a counter example of like, I thought this was the rule, but this is not the rule because this is the rule. You know, that the game is a good way to show you some counter examples to help you hone in on the real rule. Okay, so that is the build an atom. And that's what you need to be doing. And I think that's everything. If you could, make sure that you answer this question: when can your family pick up your tote? And that's it. Thanks a lot, guys.